This question, if we want to find out the kth smallest number in two sorted arrays, we can use two pointers method. Uh, then traverse two arrays, find out the kth smallest number. The time complexity will be okay in that case. I want to use the another method which is more efficient. For example, the two array, array A like this, array B like this. Let's say k equals 10. If we want to find out the 10th smallest number into array A and array B, we can compare the first the fifth elements in array A and array B, which is A5 and B5. If array A5 is smaller than B5, then we can exclude the first five elements in array A, which is 1, 2, 3, 4, 5. And next time we can let's say A left is the start index from of array A, and B left is the start index of array B. Next time we can narrow down the searching area from in array A. We can from the start from the 6 to the end of the array. And array B's range still from 0 to the last element. Why we can do like this? Let's prove it. Why we can exclude the first five elements of array A. Let's say if the 10th smallest number in is array A5. Let's say the 10th smallest number is A5, which means there are only 4 elements in A5 in array A smaller than A5, which is 1, 2, 3, 4. And also because B5 is bigger than A5, so in array B, at most there are also 4 elements smaller than A5, which are A1, 2, 3, 4 as well. So there are totally 8 elements in array A and array B smaller than A5. So A5 couldn't be the 10th smallest number in in 2 arrays. That's the reason why we can exclude first 5 elements in array A. The next step, because we narrow down the half of K's range until K equals 1, and then we compare the first at that time we can compare the first element in array A and the first element the B, the rest of the B elements of the first one in array B, and which is smaller, and return the smaller one, which is also the 10th kth smallest number. And there is also another case we need to consider about. For example, if array A, there are only 4 elements in array A, and array B more than 6 elements in array B. In this case, there is no elements in array. There are no elements like A5. So in this case, we can exclude the first 5 elements in array B, which is 1, 2, 3, 4, 5, and we can narrow down the search range in array A. Still also start from A left, which is 0 to the last element in array A, and in array B, the start the start index will be the 6 to the last element in array B. How can we do like this? We can prove it. Let's say if the if the B5 is the kth smallest 10th smallest one in 2 arrays, which means there are in array B there are 4 elements smaller than array B, and if there are 4 elements, if let's say all the elements in array A smaller than B5, which is 1, 2, 3, 4, smaller than B5, which is also 4 elements smaller than B5. So there are total 8 elements smaller than B5. In this case, B5 will at most will be 9th smallest one, won't be 10th smallest one. So so we can exclude all the first 5 elements. Okay, let's do the coding part. In this case, I want to use the recursion method. Let's first do the corner case. If array A length array A is empty, then we just only return the B the k-1 method, k-1 element, because that one definitely will be the k smallest one. Else, if B length B is empty, the same situation will return A, the k-1 repetition. And then we call the recursion. Let's finish the recursion method function. We can pass the parameter array A, and the search area start from A left, and array B, and search area from B left start from B left, and K. So first we need to find out we need to find out the base case. If A left is larger than the last element, it just avoid the out of the bounds. We need to see if A left is bigger than the last element, the index of the last element. In this case, we need to return. It means there's no element left in array A, so we can in this case we just return the B left, and B left plus K minus 1 is the K smallest number. Then we are going to see if B left is out of the bound, also like array A. Now in this case we need to return array A, the kth element in array A, except this base case. There is also another base case, which is if K equals 1, it means we already exclude we only exclude K minus K, exclude how to say it, there only we left in this case we just return the smaller one, the which we compare the A left in array A and B left in array B, which is smaller than the smaller one is the kth smallest number in two arrays. The next step, we need to find out the K divided by 2 position in array A and in array B. Let's say A mid is the K divided by 2 position in array A. We can write down like this. And B mid is the K divided by 2 position in array B. And the next step, we need to find out the A-mid, the position A-mid in array A's value and B-mid position in array B's value. We we can define a variant A value, but we need to find out if the A-mid if A-mid is out of bound or not. If A-mid out of bound, in this case, we can give the A value the max value, or if A-mid is not out of bound, we give the A value A-mid. A-mid index A-mid in array A. The same situation in array B. If B-mid is out of bound, because A-mid and B-mid won't be out of bound at the same time, in that case, array A and array B's total number of element will smaller than K. So at most there are only one either A-mid out of bound or B-mid out of bound, or both of them are not won't be out of bound. If B-mid out of bound, we can assign in max value to B value, or B-mid of array B. Then we compare these two values. If A value is smaller than B value, it means A-mid smaller than B-mid. We can exclude the first K divided by 2 elements in array A. In this case, A left move forward K divided by 2. Otherwise, it means A-mid bigger than B-mid. In this case, we will update the B left, move forward K divided by 2. And after we update the search range, we can call this recursion method again. Array A left, array B left. But another very important situation is we need to every time we need to narrow down half of K. Otherwise, we couldn't stop this recursion. This is the method of recursion. In this case, because every time we narrow down half of the k, so the time complexity is O log k. Because also the recursion, the space complexity also is log k. Oh yes. So first, A left first start from 0, and B left start from 0.